Okay, we are back. This is Techmath2. We're looking at 7.7, more solving. So let's solve for C. We subtract D from both sides. That isolates what we have. C squareds of M. Oh, so look, we don't even have to square both sides or anything. We're just going to divide both sides by the square root of M. And that's it. So again, in algebra, this would be a no-no because you have a square root in the bottom, and we'd make you rationalize the denominator. But unless they specifically say in this course to rationalize the denominator, you don't have to. To rationalize the denominator of this, you'd multiply top and bottom by the square root of M. So then you'd have that on top and that on bottom. And I'd still give you full credit if you did this, but you don't have to. You can just do this one. All right. Okay, this convert to a multiplication problem. So if you think about what's going on here, this is a fraction over a fraction. So we have M on top, and we have another fraction on the bottom. And the way to remedy that is you multiply top and bottom by this reciprocal. Okay, and then here we go. This all cancels into boop, 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 1, and then we have it like so. And that's all they wanted for that. Same with this. So you multiply by the reciprocal on the bottom, and that gets you 1, and then on the top, and then you no longer have a fraction over a fraction. You have it as just C times the square root of D over AB. All right? So I just thought I would highlight that little mathematical maneuver, all right? Because they sometimes do that with their solutions. So let's take a look at 7.8. So 7.8, we have R equals, we're looking at number 62. That's in the red book on page 327. So R is equal to quantity H over T squared. And they want me to solve for H. So this time, instead of, I guess we can square it. Okay, here. We'll go H squared T squared. So we do that, we cross multiply. So we have H squared equals R T squared. And now we don't want H squared, so we'll do the square root. Again, it is plus or minus, but you don't really need the plus or minus in this course. Algebra, if you're in an algebra class, you definitely need to remember that plus or minus all the time. So now, look, these are being multiplied, so we can let that T basically escape, perfects and leftovers. And so H is equal to T square roots of R. So that's one way to do it. Another way to do it would have been to square root it right off the bat. I think that would have been easier. If I would have square rooted both sides, we would have the square root of R is equal to H over T. And then want H, so I just have to cross multiply. I should have went with my first thought, because that was a lot faster. That was like one and done. This was a little more complicated. Either way is fine. You get the same answer either way. All right. Let's take a look at 65. This time we'll try to do it quick and efficient here for 65. We've got dk is equal to 8t over r squared, and they want me to solve for r. All right. So we're going to definitely go this route. Let's take the square root of both sides. So now you got the square root of dk is equal to AT over R. And now let's cross multiply. So we have R square roots of dk equals AT. And they wanted me to solve for R, so I'm just going to divide both sides by the square root of dk. And that should be it. R is equal to AT over the square root of dk. Again, if you rationalize the denominator, you'd have R is equal to AT square roots of dk over dk. But you do not have to rationalize the denominator. Oh, they wrote it a little bit differently, which would be fine. Here, let me just show you so you don't think this is wrong. This is fine also. If you want to put AT times 1 over the square root of dk. It really says the same thing. Look, that's top times top, bottom times bottom, and you're right back to that. So either way that you want to write it. I don't know why they have this, the 1 under the square root sign. That's probably, again, in algebra class, we wouldn't allow that because it's a perfect square. 1's a perfect square. So you have to take the square root of it, which is 1. So that's bad form to leave the square root over the 1. That's like leaving a square root of 25, basically, instead of writing 5. Okay, so then we're on to 7, 9. So this should take you back to Techmath 1. We did these extensively. T is equal to G squared N, and G is equal to PR, where they tell you eliminate one and solve for the other. So this one says eliminate G and solve for R. So we did this. We did this in 115. It's just so you might say, well, why are we doing it again? Well, because now they're going to throw some square roots and squares at us also. In 115, we just did the elimination and solving, but they kept it all not second degree, all first degree. All right, so here we are. Eliminate G, solve for R. So how do we eliminate G? Well, you just take G right here and sub it in up there. And so you're eliminating through substitution. So T is equal to, instead of G squared N, we put in that PR. And look, no more G. So we have eliminated G. We did what they said. And now they want us to solve for R. So to do that, we would first divide out the N. So we have T over N is equal to PR squared. And now we're going to do, well, I already erased it, obviously, but we're going to do the square root of both sides. And so now we've got the square root of T over N is equal to PR. And then again, we'd want to divide both sides by P. But since there's a fraction over here already, let's multiply by 1 over P. And that's our answer. So R is equal to 1 over P square roots of T over N. I think that's probably how they wrote it. Is that how they wrote it? Yep. Okay. Cool. So let's take a look at another problem from 7-9. How about 74? let's see. Oh, there's two of them, so let's do this one first. V squared G naught R naught G naught GM over R naught squared. And they want me to eliminate G naught and solve for V. Okay, so they have G naught already solved for us. So we're going to take this and cram it in there. And actually, that's going to work out nicely for us here. We have G R naught squared times R naught. So look, one of these R naughts are going to cancel. And then we're almost done. It's just solve for V. So we take the square root of both sides. And now we are done. So V is equal to the square root of GM over R naught. And whoop, done. All right, then let's look at the other one. We got A is equal to V squared over R, and we've got V is equal to 2 pi RT. And they want us to eliminate V and solve for T. Okay. So eliminate V, so we're going to take this mess and put it into there. So that is going to be A is equal to 2 pi R over T quantity squared over R. Okay, so before we go too far here, let's cross multiply and kind of solve. So we have this 2 pi R over T quantity squared is equal to AR. So see what we did there? We took the A times the R, that was right there. We took that times 1, that's right there. And so we've now eliminated the fraction over the fraction thing through cross multiplying because there was it's an equation. Okay, now we're trying to solve for T. So let's undo this squared with a square root. So we got this, 2 pi R over T equals the square root of AR. And so we still want to solve for T. And again, some of you from 115 picked up on this really fast. If I cross multiply and solve, at the end of the day, the T ends up there and the square root of the AR ends down there. I'll show my work here, cross multiply and solve. So we get T square roots of AR is equal to 2 pi R. And now we divide both sides by the square root of AR. So see, at the end result was the T in the square root of AR just kind of switched places. With the right triangle trig, that happened a lot in Techmath 1. And I had some really smart students that picked up on that really quick and just went with it. All right, so that was 7-9. Let's take a look at the run time. 7-10, we want to do, more of the same. Let's look at 87 for an example. So more of this, only this time they don't have it solved out for you, like to eliminate. They tell you what to eliminate and they tell you what to solve for, but they don't have it all ready to go for substitution like these were. So it's one more step, one more layer onto the thing here. So 87 is Z is equal to the square root of R squared X squared plus X squared, plus X squared. And X is equal to 2 pi FL. And they want me to eliminate X and solve for F. Eliminate solve for f. Okay, so, oh, well, no, they do have it solved for x. Oh, I see. So they just upped the ante by, we're going to substitute this inside of there, which is kind of buried, right? So let's do it. Z is equal to the square root of r squared plus 2 pi f L squared. So we have now eliminated x. We took that x and put it into the other one. So through substitution, we have eliminated x. All right, now we want to solve for f. That's pretty well buried in there, isn't it? So we've got squared plus 4 pi squared f squared L squared. So we cannot just apply the square root to both of these pieces because there's a plus in between. If there's a plus or minus, you can't distribute the square root. So we have to square both sides. And then it looks a lot worse than it is here. And we're going to get rid of this r squared. I'll isolate that. So we have this. We have z squared minus r squared is equal to 4 pi squared f squared L squared. And now what we're going to basically do is divide everything that is not f. We want f to stay. We want everybody else to go away. So 4 pi squared L squared on both sides. I see what's going to happen. So now we have this. We have f squared is equal to z squared minus r squared over 4 pi squared L squared. And so now we're going to take the square root of both sides. And on the top, we can't do a thing with it. It's just going to stay the square root of z squared minus r squared because we cannot distribute a square root over a minus. But on the bottom, that's all one entity. So that is the square root of 4 pi squared L squared, a monomial. So we could do that, and it's perfect square. So 2 pi L comes back out. And that's it. So a little trickier. They made us jump through a few more hoops on 10. That's all. All right. That is chapter 7.